Hey, Jay.
Hello. Hi, everyone.
Howdy.
Hey, good morning.
Thank you for joining me today. Let's give it a few minutes for people to join into the lives. As you all join the stream, if you could just comment for anyone who's streaming in and listening in the conversation, um, what role you work in. If you're an engineer, if you're working product, your name and where you work, and excuse me, your name and your role. And while the audience, while the listeners introduce themselves, if you all could introduce yourselves, let's start with Mike.
Sure. My name is Mike Reeser. I'm an agile coach and trainer with Industrial Logic. I do a lot of travel as well as coaching the teams on site, training, been traveling a lot for that too. I think that's about it.
Perfect. John, how about you?
Hey, John Fazzaro. I've been a professional nerd for a couple of decades, and sometimes I think I almost have the hang of it. I'm doing a lot of nerd coaching, but also kind of management and executive coaching as well, just trying to help organizations and teams use both the engineering and process techniques that agility has to offer to deliver better software sooner.
Nice. And last but certainly not least, Wyatt, can you introduce yourself?
Yeah, absolutely. Good morning, everyone. Wyatt Sutherland. Gosh, I've been in, when John said a couple of decades, I went, whoa. So I've been almost 4 decades, over 4 decades in software as in the trenches developer and architect. And in the late 90s, early 20s, discovered agility and started helping corporations adapt to it, and individuals and teams, and have been doing that for a couple of decades. So like Mike Reeser, we do a lot of traveling, and since COVID, we've been doing pretty much, I'd say 98% of our engagements have been remote. And yeah, like most everyone, we've really figured out how to do the remote thing, and yeah, it's pretty awesome. Yeah, I work with teams and the C-level suite and hands on a keyboard and that sort of thing. So yeah, it's a lot of fun.
Nice. And I guess I'll introduce myself. My name is Jariatu Mansour. I go by Jay. I am a product consultant here at Industrial Logic as well. Not an engineer, but work very closely with them every day. And so I'm excited to be able to host this panel today. And I see some comments have come in from our listeners. Thank you, Robert, Mark, and Drew for joining. Again, as people are pouring in and you're starting to tune in, if you could just comment your name and your role so we can make sure the conversation is geared towards the things that you're interested in, the things you want to hear about. So with no further ado, let's get into the subject for today's live. So obviously it's entitled Industrial Logic's Engineering Practices. So I think a good way to start this conversation off would be to ask, what is the difference between different software development organizations? Are they all the same? I know a lot of people think that engineering is engineering. What are the differences? I think that people may not necessarily think of right away between different software development organizations.
Wow, that's a big question. Yeah, Mike, you want to start?
Sure, I'll take a stab at it. I do a lot of consulting, a lot of traveling. I see a lot of different organizations. And I think a lot of folks think that the way software is done is pretty much the same everywhere. They don't really see, they don't think that there's much of a difference between the really high performing organizations and those that are just pretty much the pack in the middle. But what they don't understand is the fact that the folks who are really, really good are like in a completely different space. It's not like just a bell-shaped curve where some people are at the tail end. It's more like a power curve where folks who are really good are in a different space, and they're just performing in a very different way than folks who are doing it normally. I sometimes talk about the the story or the case of two different companies. One where they have software basically set up on an assembly line that anything which actually gets committed is going to go to production. There's like automation all the way through for testing, et cetera. And you'd actually have to do some sort of manual intervention to stop it from going to production. And with a group like that, if that automation or that infrastructure goes down, that's the first thing that they're going and repairing. Now, contrast that to other groups where you would like them to be able to build that kind of thing, but they're so enamored with more features that they never actually spend time creating the automation or the delivery mechanism. And they actually struggle. And they would love to be able to push out more, but the thing that's actually fighting them is the fact that they don't actually have that conveyor belt that actually sends things to production. So to me, it's night and day different. And people don't realize that there can be such a big difference.
Yeah, I'd like
Mike, that reminds me of something I heard recently, that a lot of agile techniques derive a lot of what we do derives from lean manufacturing. Well, the presupposition in lean manufacturing is that you have a factory, and what you're describing with the conveyor belt is a factory. And many teams are working basically without a factory; they're just piling up inventory somewhere.
Yeah, one of the very first things that we like to do is we call build a walking skeleton, right? And that walking skeleton is just a bare minimum. But we can go from push button, like we make a commit, builds, goes all the way through, and pushes out to some prod environment, right? It could be a staging environment or production with flags on it. We use a lot of flags to keep things available, accessible, or not accessible to the real client. And that's the very first thing we do is build that walking skeleton. So then we have the ability to every single time push something out into a production environment.
Wyatt, when you say bare minimum, do you mean like we just make a database table and push it out there?
Could be anything. Could be absolutely anything.
Wyatt, I'd like to delve further a little bit into building a walking skeleton. I know that's something that's big at IL, as far as how we practice engineering. What other factors or methods are part of the IL way or IL's preferred process of software engineering?
You mean like when we first do an engagement with a client or?
Absolutely.
Okay. So the very first thing we prefer to do is to do an assessment, a quick assessment. It doesn't have to be weeks long, could be, but it could even be a couple days where we do an assessment. And then we identify, do we have the right people, right? So from the assessment, we'll go into a chartering, and then we'll have team agreements. And the chartering is not just the team. The chartering is anyone who has an interest in the outcome of the work, right? So it would be maybe some execs, people who are doing reporting. It could be would be the product side, definitely developers, testers, anyone who's involved. And so if you think of if your organization has throw it over the wall for this component team to do something, and then some testers to do something, all of these people are part of the community. So that community then works on a chartering. A chartering is team agreements, how we're going to manage risk, how to report risks, what sort of communication. And then after we do the chartering, then part of the charting also is like, which ways of writing code do we use? Are we going to do pairing? Are we going to do mobbing? Some people may be foreign to that. So then we might try some things out. So then when we have the chartering done, then we work as a team to build a skeleton. And the skeleton is more than just a database, but the skeleton is just a bare minimum of what, it could be even just like when we say like a login screen, it could be just entering the name, right? No password, no anything, just a bare minimum, getting it out there. And now we have that conveyor belt that we can actually push something to. And then what we start doing is we continuously demo each capability that we have with the stakeholders. And when I mean continuous demoing, as soon as we're done with the capability, we'll demo it. We won't batch everything up and do a demo session, part of a sprint review, We will always do that. And sometimes we'll demo things as often as, 5-10 times a day, depending on how large the team is. So one client that we're working with right now in particular, we have 4 sub teams, and those sub teams are demoing at least a couple times every day. So at least 8 times per day they're demoing as soon as they're done with the capability. So that's sort of it in a small nutshell.
Nice. And then Wyatt, you mentioned while you were talking through those steps, pairing and mobbing. John, can you talk to us about pairing and ensembling development and how we do it at IL and how often and why that's important to the process?
Sure. Well, I guess the shortest way I could express this is that we don't type for a living as software engineers. And often, a software engineering team will be organized to split up the work and have people work on their own, so we have as many things going in parallel as possible, and that generally gives people the sense that we're going faster, we're getting more done. The problem with that, and this goes well beyond software engineering, but the number one cause for project failure in general is something called coordination neglect, which is that it's very easy for us to break down a job into the component tasks and pass those tasks out. And what we always discount is the cost and effort involved in bringing it back together to a deliverable whole. So with those two ideas in mind, the coordination neglect, the cost of integration, and the fact that typing isn't the slow part of software engineering, what we do is we embrace this sort of idea of if you think of a multi-core processor, the software team as a multi-core processor, where we've got many brains focused on the same problem at any given point. So that's basically the way we look at the practices of mobbing and pairing, and there's in addition to the reasons that we do things like that, I'll say that it is much like the way we do pairing and mobbing, excuse me, is it's an acquired skill. And we've been doing it for a long time. We're very practiced at doing it, and how you do it matters.
Nice.
Sorry, I said a lot there. Is there anything we want to go closer?
No, I like that a lot. And again, as you are all joining in the audience and listening in, continue to introduce yourselves and put your names and roles in the chat. That's very helpful. And if you have any questions or comments as the speakers are speaking, please contribute those as well to move the conversation forward. I want to ask, because John, as you were talking, it made me think about software quality and internal software quality. Mike, can you talk to us about internal software quality and if it really matters when we're talking about software development?
Sure. A lot of folks, when you talk about software quality, they think in terms of what the user sees or what the stakeholders see. They don't really think about what do the developers see. And I believe that internal code or code quality or internal quality is, how do I say it? It's a precursor to lagging external quality. And that is that as the quality internally starts to degrade, you will eventually start to see the external quality degrading as well. But the problem is that sometimes that feedback loop can be kind of long. And so by the time it's actually being detected that, the code base is kind of suffering, you've got a real problem. And so internal quality is actually, your best place to start catching when the software, the code, isn't representing what the system is really trying to do or is trying to do best. And so you need to constantly be refactoring. That's one of the other things about ensemble or mob programming, is the fact that often when a developer is working solo, they're shouldering a lot of burden. And you would also think about the sorts of decisions that they might make. And they'll go, oh, I don't want to touch that. I don't know what that might break. And so one of the things that I see in ensemble or mob programming, like John was talking about, is there's a tremendous amount of courage by the team to actually fix something that if they were all working solo, it would have bothered all of them individually, but they never would have tried to tackle it. But when they're actually together, there's a certain amount of courage that just, it emerges in the group, and they decide to go ahead and fix it. And so when you have an internal code quality problem, one of the best things I would tell you to do is start mobbing on it, start getting that ensemble working on it, because it's like having a constant review while you're actually trying to code or to refactor. So anyhow, hopefully it's clear that internal code quality is important, and it's a precursor usually to indicators of external quality.
Absolutely. And speaking of fear, we actually got a question submitted by one of the listeners, which is, why are managers often so afraid of having code changes go to production automatically? Is it that they don't trust the developers? Who would like to take this one? Feel free to mount on it if you need to.
I'll take a start at this. So I wouldn't say all managers, and I've seen teams have fear of going straight to production quite often. And it's not, and so when we talk about trust of the developers, it's the trust of the code base. And so the practice that we use is making sure that we have, you heard Mike say earlier about the feedback. Well, another feedback that we have that lets us know that we have good quality is the unit test. It provides immediate feedback to the quality of our code, right? If we've broken something else. And we adhere pretty strongly to test driven. It's not like we do it for absolutely everything, but if there's a business or a logic change to some sort of business, we'll make sure that we'll have tests around that. And that's our immediate feedback loop in seconds and milliseconds. And so if people, I'm not going to say managers, if people understand that is your safety net that will catch you, then your ability, your confidence of going to production is higher, right? If you don't have that feedback loop, then your confidence is going to be unknown. Like, I have no idea if this is going to break something. Well, when we write code, we have a pretty darn good idea if it's going to impact something else. So, and yeah, it's not don't trust the developers. They may not trust that the code has that safety net. And so that's our feedback loop. And if it doesn't have tests around it, then our first thing that we do is we write characterization tests for any legacy code. Right. So I think if we want to, we can dive into what is characterization test and that sort of thing. But anyway, so
well, I've got a sort of a follow-up on what you're talking about, Wyatt. You're talking about how the unit tests interact with deploying to production automatically. And to go back to the question, is it that they don't trust the developers? I'm going to say in a brief, yes. But like you said, it's also they don't trust the developers, but not as people. They don't trust the code effectively to go successfully. And you know what? I don't blame them. I don't blame them because in an environment where you don't already have other things like these, my point is these practices interweave together. It takes several of them executed together to create, software the way that we like to create software, including deploying to production automatically. I would never take a code base that didn't have automated tests with a team that wasn't used to that, working in that way, and say, let's turn on the switch and just deploy every commit to production automatically. I think that's a terrible idea. What you need in place first is good architecture that enables good testing, that enables a culture of refactoring and safety. Then we can start deploying things to production automatically. And so it's kind of the interdependency of these practices that makes any one of them work.
Yeah.
I don't want to belabor it, but I've got yet a third point. Is it all right if I bring that one up?
Go for it, man.
All right. Well, I mean, part of this idea is, do we trust the developers or not? But I think part of what you have to look at is what is the system that those developers are working within, which is part of what John was bringing up. And that is do you have these interrelated practices which support each other? Or, for instance, and here's one of the things that I was seeing is kind of like, here's the problem. There are some organizations that are driving so hard for the developers to be done, quote unquote,
That's right,
that they call things done early.
That's right.
And then they basically pass it off to a tester. And then the tester goes, oh, no, you're not done.
That's right.
And then throws it back to the developer. And so in that kind of an environment where they're incentivized to call themselves done, but not necessarily quality, professional, safe, then it's the system that's actually that they're working in, which is actually in part at fault. So you can have systems where, yeah, you can actually go straight to production, but you've set up the safeties and you've set up the incentives so that they're not just about being done, it's about being working and being right.
And that makes me think I'd like to go delve a little bit deeper into the idea of testing. Do you all, as IL engineers, TDD, and how often?
It's my preferred. Yeah.
Yeah, I mean, for us, that's our default way of working. I mean, just writing. We think, what's the design of this? Oh, well, let's just write a test, right? So we have a whiteboard image of what we've talked about. We always do some sort of whiteboarding. And then, okay, well, then we do some discovery tree of things that we need to do. Yeah, there you go. And then we delve into, okay, well, let's, what are we trying to prove? Well, let's write a test. Right. So we're always starting from the perspective of what's the expected outcome. And we write a test to prove it. Right. So when we talk about red, green refactor, we really are doing that. And I wouldn't say we're zealots, but it's really our default way of working. Sometimes we won't write a test. But anytime there's business logic to it involved, we will definitely have a test for it.
Wyatt, I think one of the most confusing things about test-driven development to developers and teams that don't practice it is that the code that gets produced by test-driven development it looks completely different from code that wasn't built with it. And it's hard to see how you could test drive your code when all you've ever seen is code that's not been built using test-driven development. There's an architecture as a prerequisite. You have to have sort of a separation between what you identified business logic code and like your plumbing code that interacts with third-party libraries and frameworks and things like that. And that doesn't naturally occur unless you've done it on purpose and or used test-driven development. So I've found that I've tried to test drive code where it's all mixed together, which is most code out there in my experience, but it doesn't make any sense. And so we tend to, sorry, go ahead.
No, finish, please.
I was just going to say, so we tend to, as people who practice TDD, we tend to forget, I think, there's that prerequisite in there and we assume that it's there. And so we might have conversations about TDD with people who don't see it that way, who don't understand how code could behave that way, or could be isolated and tested in that way.
So there's something that I've seen when people say, "Yeah, I do test first," but it's not test first. It's writing unit tests afterwards, and that code it has coverage, but the code tends to be really snarly, right, and difficult to follow because they've cobbled on some making methods much longer and so on and so forth. So yeah, when we talk about TDD and test first, I think it's really important for everyone to understand that test first really does mean I'm writing a test first, not that I'm writing a test to create coverage. Because I've worked with many teams and they go, "Yeah, we do test first." And then I'm pairing with them or in the mob, and no one is writing a test first. Everyone's implementing, and then they have a story. They're going to create the test, right? So test first. First.
We have a comment from Andrew or Drew in the chat, and he says, "I agree with trust of the code base. Managers who struggle with this usually haven't seen the results of investing in TDD, pairing/mobbing, frequent demos, automated deployments, and other development practices." When we're talking about different engineering practices, some obviously can take more time than others. Which would you all do first and why? And you can each take this question if you have different answers or perspectives.
You're saying which of the practices would we begin with?
Yes.
Okay.
Well, someone just asked a question. Would you introduce, and that's part of this, right? Would you introduce TDD in a dev team when there's already a code base that has hardly any tests? And I would go, absolutely yes. And then we talk about that. Those are called characterization tests, right? So you have the behavior of the code already there. Let's make sure that we understand what that is, right? So first, wrap all of the implementation with test, and then you can use your SonarQube or whatever system you're using to see what the coverage is, and then you can start refactoring too. So now that you have the behavior and the feedback from your test, now you can safely start refactoring. So to your question, absolutely yes.
I would add to that while we're doing that, in the process of introducing tests, like Wyatt described the characterization tests, I would introduce some pretty strong architectural refactoring and introducing some boundaries so that the next tests that we write are faster and easier. I think in terms of the practices that we use, what the thing that stands out to me about all of them together is that these are things that remove what's slow about software development. And I think TDD is definitely one of the early ideas I would introduce into a code base to kind of start that cycle. Also, architectural separation, like I'm describing, of dependencies from logic, and I think where you start has to involve I think pairing and mobbing, so that everybody sees you introducing these things together and the ideas spread. So if one of us is, if we're just off in a corner doing these amazing things and everybody else is proceeding with business as usual, you're not going to make any progress at all.
I've seen so we've been in organizations where they say, well, we do pairing all the time. And when we go and we observe, yeah, there are two people sitting together, but one person is writing the code, right? One person is doing everything. The other person is, checking on their Amazon order, that sort of thing. So, there are patterns to pairing to keep everyone involved and making sure that we're doing true pairing, right? Not just sitting together. There's a huge difference.
Actually, I have a couple of follow-ons on that one. One is, I was someplace where they were using sort of a Shu-Ha-Ri approach to trying to adopt and transform. And they were asking me, what's your Shu, which is the very beginning level for like TDD. And I said, okay, new code comes with new tests, and changed code comes with tests around the changes. Now, I'm asking for these to come together. I would prefer that they were writing them test first, but I'm essentially just getting them to bring them together and to commit them together. So that new code comes with new tests and change code comes with tests around the changes. Now, if you keep doing that, you don't have to, some folks want to stop and try to, characterize the world. And I'm like, nope. Just use your change process, your backlog. What do we need to change next? And just apply those rules as you go. And what will happen is you'll find that parts of your code base are more often visited than others. And so as you actually start to apply tests to those areas, like little areas of stability with good testing will start to emerge out of your code base, and they're where you happen to be spending time anyway. Let me think. There was another point that I was going to make besides the TDD one. I'm going to have to pass. Sorry.
No worries, it's fine. John, you mentioned earlier we were talking about that way to try to remove some of the things that are slow. I know a lot of software development organizations use story points as a way of measuring time, right? As far as how long it'll take things to get done or how long teams can expect. But pretty certain that you all don't use story points. Can you explain why that is?
Yeah, it's been a long time since anybody around here, I think, used story points. And story points were an interesting idea, trying to decouple the linear relationship of how much time we think it's gonna take, to the non-linear nature of software development, where we don't know the work until we've started to touch the work and it reveals itself to us. I think the fundamental problem, it's not necessarily story points, it's guessing. The fundamental problem with trying to predict the work in that way is that we're guessing. And you could say, yes, it's an educational guess or educated guess. It's a guess based on the engineer's experience, and boy, this person's seen a lot of stuff, so we trust their guess. But the fact is, it's still a guess, and it's full of cognitive biases and just not really useful things that are wrapped up in that number. And that's why estimation is so fraught. It's why it's so hard, and so often it's wrong. The preferred way that we predict, and the problem is, with all that, the guessing and estimation being hard, we still have to give an answer to when will it be done.
Yeah.
And we have a completely different way that we prefer to do that. And you may have heard of this. It's been around in the air for, I don't know, 5-10 years or so. But we use probabilistic forecasting. We basically we keep data on how long it took us to do things in the past, and using sophisticated statistical analysis, Monte Carlo simulation, for example, we can project forward in the same way that meteorologists predict the path of a hurricane. We can project forward what the likely outcome of getting something done by a certain time is.
Nice. We do have a question in the chat from one of the listeners. They ask, which of the practices that you introduced in the team face the biggest psychological resistance? TDD, mild programming, or pushing changes to production?
Yes.
Yes.
I think it's I'm going to say it's anything that requires engineers or an engineering team, or even the managers that support them.
Yeah, the organization.
Yeah, anything that requires those people to change the way they work if they don't see a reason for changing it.
Yeah, I call that loyalty to legacy behavior, right? Legacy thinking, right? And like anything that we do, exercise, practice violin every single day, a couple hours, whatever it is. If it's a change, it's difficult, right? And you just have to try it. You just have to. We use the word experiment. Let's just experiment for a day. Let's experiment for half a day. Let's experiment for a week. We just do small experiments on one thing, help break the ice.
I'll also add to that, Wyatt, that we're talking about like that kind of change, getting people to change their behavior, especially if they aren't interested in changing their behavior. That's more of a training coaching scenario. And one of the things that I've found when working with exclusively software engineers who work the way we do is that we just can get to work. We don't have to go through that that transformation, that changing people's mind about how we work, because everybody in the room is already read in and practiced in these techniques, and that makes an enormous difference, I think.
I think you need to start encouraging change. Just change some things up. A lot of folks, they're in there, but this is how we've always done it, and you're coming in with some change. So part of it is they're just resistant to change. So having them start to do things that they haven't done before, experimenting with new things, and of course introducing TDD or ensemble programming, etc., will help to also break up that legacy thinking.
I want to switch gears for just a moment. So earlier in the live stream, one of the listeners commented that they joined the live because they wanted to learn how technical practices can impact or make a difference in business agility. I wanted to ask about losing my place here. I wanted to ask about iterative development or requirements up front, because I know that's a big change that a lot of people do struggle with. Which do you all do and why?
Well, can we answer the first part? So
Absolutely.
yeah, so there was something in there I didn't hear. I didn't understand quite the full words, but something about doing more agility or being more agile. I'm a firm believer that we should never do anything just to be agile. It's about the outcome, right? Like, do we want to get products out the door faster? Do we want to get the products out the door with higher quality? Do we want to get products out the door with greater safety? You know, it's probably yes to all of those, right? So that's the reason to do it. You don't have to call it agile. We don't have to be doing agile. They're just practices that we do, and they just happen to fall under this umbrella that most of us call agility.
Mm-hmm.
So, and to the question about iterative versus upfront requirements,
yeah,
it really depends. I mean, we prefer iterative, so like a time and material. That's our preference because the client can change their priorities at any time. We're working with a client right now where we have to actually do the requirements up front because it is a fixed schedule and fixed budget. So we had to do all the requirements and then we had to freeze them. And we froze them based on acceptance criteria. And so it really depends on the client, but our preference is that we give the client so much flexibility, and that flexibility is in time and material. And then we do requirements as we go. Like, we don't want to do something, we don't want to work on the requirements and understanding them now when we're going to work on them in 6 months, because in 4 months that idea might change, right? And the client may not want that thing anymore because of either changes in his business, in their business, or whatever it may be. So that's our preference. But if the client is adamant, like, we have to do all of these things, then what we do, we will then do the requirements up front. But that's not our preference. And it's not, it's not our preference because it's not what we want to do, is because it really gives the client tremendous flexibility based on the feedback of their marketplace, of their customers.
Nice. Thank you for that, Wyatt. We have another question from one of the listeners. Michael asks, does IL find coding standards useful, or does ensemble programming cause a natural converge? It's a great question, Michael.
Yeah, I'd say both.
If you're talking about a documented, like we've documented in this, in this Google Doc or Word doc or something over here, how our coding standards are, that's not something that I think we've used before. And there is, and a lot of it is because there's a natural convergence of that in a mobbing and pairing environment. In addition to that, we also regard the code base itself as the documentation, as the one true source of truth about what it is, what it is that we're building and how we like to build it. And so, yes, I think coding standards naturally emerge, and they are embodied and documented by the code base itself.
Nice. And I think that's reflective of another comment that Jeff Langer posted in the comments. He said, Michael, more of the latter. The code demonstrates the standard and evolves with us. Why is it important that we establish practices that can evolve versus just setting from the beginning a set of standards that everyone has to follow to make sure that no one strays from it from the beginning? Why is it important that that's an evolutionary process?
Because I think the fundamental nature of software development and this kind of work is that we can't know the value of what we're doing until it's done and delivered to people. We can't, not that we could work really harder to find out. We can't know until it's done. And so everything under the tent of, what Wyatt was talking about as agility and all the the practices that we're talking about, those are really geared to mitigating that problem, that fundamental problem of we don't know how this is going to go. We don't know what's going to happen, and we have to act like it. So we allow for, rather than like our preference is not to do requirements up front, because that's when we know the least about what's going to happen. And it automatically excludes any learning that we might pick up during the process of implementing something, learning about the product, learning about the code, learning about the technology, learning about the team or the end user. All that stuff gets thrown out if we try to pretend that we can get everything locked in up front, code standards or requirements.
Nice. We do have a follow-up question from the previous one. So Michael says, Wyatt, fair enough. Can we get the supposed benefits of Agile without the technical practices? He just took a course with Uncle Bob, and he has a very strong opinions on this.
Of course, Uncle Bob has a strong opinion. So anyway, it depends on what's the goal, what's the outcome. Is it you want to have you want to do things iteratively and in small batches? There's some benefits to that. If you don't have technical practices, then those small batches can become large batches. So I think that all interplay. But if we just look at like just the process, like maybe doing a lean flow, Kanban lean flow versus, now this might spook some folks out there, but we don't do sprints per se, right? And we prefer not to do iterations. It's just flow. We have a Kanban, we have a backlog, and then we just continuously pull work. Yeah, we could measure every week, and that's what we do. We do take measurements every single day, every single week for throughput to check our forecast. But we don't set time aside to do story points or do backlog grooming. We're constantly doing grooming, like every single day, small bits, like 15 minutes, 30 minutes here and there. But the technical practice really feed into the ability of delivering things with credibility, with confidence. And if we don't have things wrapped in tests for feedback loops, that's an area that I find very difficult to believe that it's not going to, even if we do small batch development, to create like large batches of things that we have to come back and fix. So, we're constantly measuring, what defects do we have coming back? We strive for 0 or near 0, and we're pretty darn close to that, quite often. And if we're not doing the technical practices, I could go to Vegas and probably bet that's going to slow us down.
Yeah, and I want to add to that too. So our CEO, Josh Karevsky, released a book earlier this year called The Joy of Agility. And in that book, he describes agility as quick and graceful movement. And so to your question, Michael, can you get the supposed benefits of agility without the technical practices? I'm going to go out and say no. And I say that because I'm just going to say, I don't think so. And does that mean that your organization can't be successful in accomplishing their goals? No, that's not what that means. You can absolutely build great products. You can absolutely have great teams without some of those technical practices. But when you're talking about achieving those outcomes in a quick and graceful way, in a way when you're constantly learning, in a way where you're constantly avoiding pitfalls, I don't think the journey there will be as quick and as graceful without some of those technical practices, because those practices, develop the team to work in a way that eliminates waste or reduces waste and gets you closer to building the right thing at the right time in the right way with levels of quality. So I will say that.
Amen.
I'm glad you asserted that, Jay. I agree 100%. I agree. It's the image that comes to mind for me is, yeah, you can run with your shoelaces tied together, but not in nearly the same way you would if you had your shoelaces not tied together. So the technical practices in my mind is an image now of Legos, and do you want like fully formed like giant plastic pieces that you sort of have to work with in large chunks, or do you want the individual tiny Legos, that come with the classic set. And that when we engage in these technical practices that we're talking about, you get the flexibility of working with smaller bits. And what that means is we're not doing more work than we have to in a given iteration to get the results of the experiment that we're doing on the product at that point to learn what we should build next. And that's like at the heart of software agility.
Absolutely.
I was imagining a high functioning team that was using extreme programming practices, and then someone says, okay, now keep going, but remove all those practices. And I'd be like, yeah, you've you've just tied their shoelaces together. Very good, John.
Nice. And I think one of the commenters one of the listeners in the comment section stated it very well. And Kevin said the technical practices that we use are generally things that we found work well to support the non-technical practices from the Agile world. So the technical practices are normally not the goal, but they're the key enabling factors towards being Agile from our customers' perspective. And that's something that I think that I couldn't have said it better myself, right? Yeah, they're key ways to get there. And again, you don't have to do them, but they definitely enable the team in order to move more quickly towards their end goal. I do want to take a quick side to promote some events that we have coming up with IL. So IL has a couple of events that are coming up. I'm going to pull the slides up here, maybe. There we are. So we have two upcoming events. On September 13th, we have another live session about remote ensemble development at 7 a.m. Pacific time. And then on the 15th of September, we have better product management with probabilistic forecasting, also a live stream at 9 a.m. Pacific, 12 p.m. Eastern. So if you have time, definitely attend those. And we also have some promotions, which if you stick around to the end, we'll outline those for you, and you can take advantage of some of those specials that we have coming up. I did want to go back for a moment and talk about the IL's engineering practices, and I wanted you all to speak firsthand about how you view the IL talent in terms of engineering practices. I know, again, I work in product, but I worked alongside a lot of you and saw the effectiveness of your teams. And I think sometimes it's hard. We try to be humble and be graceful and leave space for others who have who practice software development a different way, who maybe have different beliefs or maybe aren't comfortable with a lot of the technical practices that we use. But I've seen firsthand how effective that they are in building products and developing teams to build better products. So if you all could speak to just a quick brag session about why you feel IL engineering's talent is the best, and what it's like to work as part of an IL engineering team. I would love to hear that. And I'm sure the audience would too.
What strikes me about the engineers at Industrial Logic is just the staggering amount of experience that they have. And I've worked on a lot of teams with software engineers of varying experience, and that's good. That's good to have lots of different experience levels on board, but there's just really there's nothing that replaces having done this for a long time. And I'm not just talking about the kind of experience where you've had the same year of experience 20 times. The people that I've worked with here have legitimately decades of experience under their belt.
I think having a common set of values as well as the practices is good too. Everyone at IL is interested in making sure that the customer is seeing value. It's not just about billings or just about revenue or whatever. Is the customer receiving value? And everyone's very focused on that. Like John said, you get to work with so many great people. I'm trying to think of the number of authors we've actually got who are working with IL. I think
you said authors of
books.
Yeah.
Wyatt?
Yeah, I was just thinking, we always want every single IL developer that I've been engaged with, especially on this project that we're working right now, everyone is so interested in making the customer happy, right? Doing the very best thing, not leaving any stone unturned. And it's not written anywhere. It's just our sort of default behavior. And often we'll have cohorts come through our training program, and some of them will stay and join IL. And we do this when we're working with clients. We'll have a cohort, and that cohort really learns our way of working. And some of them have some years under their belt. Some of them are out of college, but they start from the very beginning of not just test-driven development, not just how to pair, not just how to do Gherkin-style writing of acceptance tests or whatever it may be. It's really embodying the IL way. And when I think of all the developers that are in IL, we have we have different behaviors, but we have similar mindsets, right? And so that quality is utmost the very first thing. And we know the techniques of achieving that, right? We know how to do discovery trees. We do story mappings. We do test-driven. And then we're so comfortable in pairing and mobbing. And we call it teaming and ensembling and sometimes mobbing, but they're all the same thing. But we just flow through that so easily. And then when we work with others in the industry who are not part of IL that have the same mindset, it's like there's absolutely zero tension. And that's just such a beautiful thing. So when I think about our way of working and when we work with others who are partners in the industry, it's an incredibly generous and considerate community. That's how I would sum it up. Very considerate, very thoughtful. Yeah.
I want to quickly address a question that one of the listeners proposed, which was Michael asked, how does IL approach larger testing? He just read software engineering at Google, and they talk about single process tests, single machine, and large. He hears much about quick automated testing. Does anyone have a quick answer for Michael?
Well, in seeking, the shrinking of feedback loops as much as possible, I think our preference tends to be, if you can write a unit test for it, do that. Where unit tests are, they're good at testing the internals of a piece of code, a function, a class, something like that. And we tend to build essentially a mountain of unit tests as we write our code, since we're doing test first development. In most cases, there are absolutely exceptions to that. Test cases we cannot prove out with a unit test because of the deterministic isolated nature of that kind of test. And so we have to use a larger test, maybe an integration test or an end-to-end test, or some kind of longer system test. And we use those, in my experience, we use those by exception when we need to, because they are slower, they are more fragile, and they're essentially more expensive all around. But it's still faster than a manual test and more reliable.
Thanks. So if we can pull up slide 17, I wanted to take a quick moment to highlight a special that IEL has coming up. So as a big thank you to everyone for joining this live, we are offering a 20% discount on our next public technical excellence workshop. So you can use the code ILENG23 to get 20% off of the technical excellence workshop. That's going to be held January 8th to February 29th. So you have a couple of months to gather your teams together. And this offer is good through September 18th. I would not wait because seats do fill up fast for the workshop. It's a workshop we've been doing for years and years. Always gets great reviews from the teams that participate. So again, the code is ILENG23, and that gets you 20% off of the technical excellence workshop. offer is good through September 18th. And if you do have any questions about that, feel free to reach out to the IO page, from whatever platform it is that you're joining us from. And if you have been intrigued by any part of the conversation today and you want to have your own personal Q&A, maybe you have some questions that you were too shy to ask, or maybe you have questions that'll come to your mind as you reflect on the conversation later, feel free to screenshot or copy this QR code here on the screen, and you can reach out for your own free Q&A session with the IO Engineering Services team. We have a few minutes left in the live. Are there any parting thoughts that you all want to leave with the audience before we drop? I know we've covered a lot of different topics, a lot of different technical practices. Again, I think we highlighted at the beginning that there are major differences between different software development organizations, and that we all here have had a great experience with working with IO in that capacity. So are there any takeaways that you would like to leave the audience with?
I guess I've got one. I think one of the things that I hate to see in software development is humans having to do repetitive tasks. Humans should be doing thought work, in my opinion, especially in this particular career. If you have repetitive tasks, find ways to script it or automate it. Mm-hmm. Some folks ask me they think they're asking me one question, but they're asking me another about manual testing. Do I think that there ought to be manual testing? Yeah. But it ought to be exploratory testing. If it's testing that you can actually script or automate, you want to script it or automate it. You don't have to keep these folks doing the same thing, week over week over week. That should be done by developers, because developers know how to maintain code, at least they should. And so your test code is code as well, so have them maintain it. But basically, I'm about freeing up people to do what they're actually really, really good at. And repetitive things should really be done by computer.
Thanks, Mike. John, Wyatt?
Thumbs up on that, Mike.
I don't know. I think just coming here, I've been on a lot of software teams. I've written a lot of code, not as much as these guys, but there's the engineering practices that I get to use here and work with other people who are already into using these practices are like they were advocated they were starting to be advocated back in the 90s, even before Agile was Agile, and it's interesting how slow they've been to catch on through the rest of the software industry, and the fact that they're in play here in full effect on teams of IL engineers. It puts us decades ahead of other software teams I've been on. And I think it was William Gibson said once that the future is already here. It's just not evenly distributed. And that's how I feel. That's how I feel about working with industrial logic engineers, is that it's not evenly distributed. It's all kind of right here.
Nice. That's a beautiful way to put it. Wyatt, your thoughts? Any imparting thoughts you want to leave with the audience?
Yeah, I would encourage anyone to just try anything, right? And so someone said, what would be the first thing you'd start? I mean, you could even start by collecting your throughput, right? And then figuring out and start using a Monte Carlo through the spreadsheet as an example of just starting something, or just start butting up with someone and pairing, or do some try pairs and write code together. Do a ping pong style where I would write a test and Mike would implement it. Mike would write a test and I would implement it. That's a fun way of engaging. And pretty soon you'll see your full day just like disappeared, and it's like, whoa, that was really intense. So I think pairing is a great thing to start with. But I think anything, if you just start doing something and experimenting. I really like the idea of experimenting, no matter what I'm doing. If it's building a house or practicing the cello or doing anything, if I don't know how to do it, I will just at least try. So have the open mind and just try to do something. Yeah, Garrick says code katas. Yeah, definitely. I'm a huge fan of code katas.
Nice. Thank you for that. And I guess as an imparting note, thank you to everyone who joined the live today. A recording will be posted on YouTube if you want to go back and watch it, or if you want to share with someone who you feel like would benefit from this information. Again, take advantage of the free Q&A session and that 20% off of the Technical Excellence Workshop code. We look forward to hearing more from you, working with you potentially. And thank you all for having me as a host in this conversation. I know that amongst the IL engineering team, there's literally hundreds of years of experience building better software faster, better software sooner, excuse me. And we would love to be able to share that with other organizations. So thank you everyone for joining us today. Have a great weekend. And we look forward to seeing you next Friday at the next IL Live event.
Thank you,
Thanks
Jay.
for hosting, Jay.
Thanks, Jay.
All right, have a good one.
Thanks, guys.